Good morning, sir. I am Monia Begum from 3rd BTech ACE department and my roll number is 23401A0476. Today I am going to tell about risk pipeline as part of the CA2 assignment in a computer architecture organization and subject code is 23ECE504. Risk pipeline, which is also known as a reduced instruction set pipeline. Risk pipeline overview. Risk pipeline, which is a reduced instruction set computing, focus on simplified instruction for faster execution. A pipeline allows multiple instructions to be processed simultaneously at a different stages. Combining risk architecture with pipelining significantly improves the CPU performance and the throughput. Introduction. Descriptor. Architectural trend. Early computing had a small simple instruction sets. Later instruction sets grew large complex leading to complex instruction set. Risk emergence. In the early 90s, designers recommend computers use fewer instructions with smaller constructs that executes much with the central processing unit. Definition. Risk attempts to reduce execution time by simplifying the instruction set. What is a pipeline? In CPU design, pipelining divides the instruction processing into multiple stages such as fetch, decode, execute, etc. It enables overlapping of instruction execution, increasing overlap, CPU speed. Paper pipelining depends on minimizing hazards and delays between the stages. Basic risk pipeline stages. Pipeline stages include instruction fetch, instruction decode, execute, memory access, and a write back. Each stage performs a specific for instruction processing, allowing parallelism. These stages are designed to be uniform and simple for efficiency. Core risk characteristics: instruction set size, addressing modes, memory access, operation, instruction format, execution speed, and control unit. Comparing risk and six pipeline. Risk pipelines are generally simpler due to fixed length instructions and fewer addressing mode. Complex instruction set computing pipelines are more complex because variable length instructions. Risk pipelines emphasize speed and efficiency after achieving high clock rates. Hazards in a risk pipelines. Data hazards occurs when instructions depend on the results of previous instructions. Control hazards are caused by a branch instructions alternating in flow of execution. Structural hazards happen when hardware resources are insufficient for overlapping instructions. Handling data hazards. Forwarding allows data be passed directly between the pipeline stages. Stall techniques introduce delay to resolve hazards when forwarding isn't possible. Compiler techniques like instruction recording help minimize hazards. Pipeline hazard solutions. Hardware based hazard detection logic identifies and manages the hazards dynamically. Software techniques involves recording instructions at compile time. Combining both approaches helps to optimize the performance and reduce stalls. Pipeline challenges. Handling hazards effectively requires the additional hardware and complexity. Branch misprediction can cause the significant performance and penalties. Balancing pipeline depth with a hardware cost is critical for effective CPU design. Advantages of the risk pipelining: increased instruction throughput due to overlapping execution. Simplified hardware design which reduces the complexity and the cost. Faster clock speeds are achievable because of the uniform instruction execution. Example of RISC pipe processors and the pipelining. ARM processors are widely used in RISC architectures with a pipeline features where MIPS processors exemplify the classic RISC pipelines with a 5 stages. RISC-V is an open source architecture supporting the efficient pipeline implementation. By all these, we can understand easily about the risk characteristics of pipeline. Thank you.